A catalyst ignites a spark. Through gradients and copying, that spark becomes code, control, and mind. A star does not choose to make life's ingredients. It collapses. Fusion forges heavier nuclei. A supernova does more than scatter matter. It creates chemical ecosystems. Shock fronts compress gas. Radiation drives reactions. And freshly forged elements seed future clouds. The first code appears where matter supports reliably copyable processes. The chemical niches set the stage for processes that can record and stabilize possibilities. But the deepest bookkeeping begins at the quantum scale. At microscopic scales, the world is probabilistic. Particles can occupy many configurations simultaneously. Correlations can span distances in ways that defy classical intuition. But the book we read is not the raw quantum grammar. It is the stabilized text that emerges when quantum systems interact with the world. That stabilization is decoherence, the process by which coherent possibilities become effectively classical records through entanglement with an environment. Once physical interactions can produce stable records, chemistry can discover templates that copy themselves. Information becomes a persistent causal player. Life is what information does when it builds machines that copy and preserve it. The universe's deepest system doesn't compose new matter, it composes new meaning. Once patterns stabilize into replicable forms, they become the substrate for heredity, evolution, and function. Information alone doesn't sustain itself. It needs mechanisms to sense, regulate, and steer material processes. If life is information with a body, then complexity is that information learning how to steer. Genes don't just store recipes, they participate in living control systems, sensing conditions, rewriting internal states, and coordinating action across many scales. The catalyst is no single molecule, it's the networked strategy of chemistry that keeps itself going long enough to improve. When control systems are shaped by selection across generations, information processing strategies themselves become subject to evolutionary optimization. Evolution is nature's oldest optimization method. Generate variation, filter it by survival, and let the resulting patterns compound over geological time. What began as accidental replication becomes an algorithm, one that discovers function without a designer. The same processes that let evolution discover solutions can be internalized. Systems that model, predict, and deliberately redesign information constitute minds. Minds compress past regularities into predictive models, converting passive record-keeping into proactive agency. When information learns to copy, then to control, the next step is to model, and prediction turns passive bookkeeping into hypothesis-driven action. Closing. What becomes the catalyst? From quantum bookkeeping to biological memory, from metabolic control to evolutionary optimization, and from adaptive brains to designed models, the arc is complete. Information that began as passive record became replicator, then controller, then predictor. Each transition deepened agency. Matter learned to preserve patterns. Patterns learned to steer processes, and processes learn to anticipate outcomes. Now the question shifts. What happens when we can write catalysts ourselves? Not the stellar fusion that forged the elements, nor the molecular copying that gave rise to life, but intentional design, engineered systems that sense, model, and act with purposes we choose. The final notes of this book do not answer that question. They gesture toward it. How do we align power with wisdom? How do we ensure that the next catalysts amplify flourishing rather than erode it? The universe began with a spark in a vast galaxy. That spark became code, control, and now, perhaps, mind. What it becomes next is a story we are still writing.